Welcome to the Capra GIS tutorial, Probabilistic Risk Assessment at City A, the island. Once you have opened Capra GIS, the files required for this tutorial must be loaded into the program. To do this, click the blue folder icon in the main Capra GIS toolbar. Next, browse for the path in your computer where these files are saved. The required files are located in the Capra GIS installation file in the Ejemplos folder, which is in Isla Capra. Load the shapefile into the Contorno folder. Next, load the shapefile that contains exposure data for City A. This file is also located in the Isla Capra folder in the Ciudades folder. Load the Predeo Ciudad A shapefile. To view the attribute table for the exposure layer, go to the Attribute Table panel at the bottom of the screen and click Update Attribute Table. This action displays the attribute data table of assets in the exposure database. Note that there are three important fields in this table. The Valfis field is the replacement value of each building. The Valhum field has the occupancy of each building, and the SE Sismo field defines the construction type, or in other words, the vulnerability function associated with each building. Next, load the seismic hazard file to Capra GIS. This file is also located in the Isla Capra folder and inside the Amenaza Sísmica folder. Note that the AMI toolbar is now enabled and can be used to browse through the AMI hazard file. This particular AMI file is composed of 1,848 stochastic scenarios, each with 23 different intensity measures, with each measure defined by 2 statistical moments. For better viewing of seismic intensity values, set a local scale and high resolution. Next, save the Capra project to your hard drive. To do so, click Save Current Project in the main Capra GIS toolbar. Save the project as earthquake_probabilistic. Next, Risk Assessment will be configured. Go to the Capra Project tab. Click Project Configuration Wizard. A general information form is displayed. Enter the required data into this form and click Accept. Then go back to the Capra Project tab and click Project Configuration Wizard. First, the type of analysis must be selected. Select Probabilistic. Next, site effects are configured. In this case, there is no data on site effects for City A, so leave this field blank. Next, select the exposure database for risk calculation. In the list, check the City A database. Finally, calculation temporalities must be configured. Temporalities are used in Capra GIS to define hazards that occur at the same time. In this case, risk is assessed using only one hazard, which means that only one temporality is required. The temporalities table contains the name of the hazard file, the name of the vulnerability definition file, and checkboxes for each temporality. Click the vulnerability cell for seismic hazard and then click Change the associated vulnerability function, located to the left of the table. Go to the Isla Capra folder inside the Vulsismo folder and select the Vulsismo DAT file. Next, check the box below the first temporality field header. Click Next to move to the next step. In this form, in the upper panel, you can review the project configuration. You can also view the project log in Notepad by clicking View Processing File. To start the risk assessment, click Calculate. Calculation progress is shown in the right of the window. In the lower left corner, messages are displayed with information on the process being performed by the program. The calculation may take a few minutes, since Capra GIS is computing loss probability distributions for each hazard scenario in the selected AMI file. Once Capra GIS has run the risk assessment, the results in terms of expected losses are reported by location and for the entire exposure portfolio. The project is then locked, which means that nothing can be modified in this project's configuration. The Restart button unlocks the project. But be careful, because when the project is unlocked, the program deletes all previously generated results. Click Next to move to the next step. In this window, you can quickly review the results. First, you must select from the results list the data table you want to view. Select the Predios_Ciudad_A_Riesgo DBF table. In the analysis data list, select the PRF field, which corresponds to the estimated annual economic loss related to the exposed value. Capra GIS automatically computes statistics associated with the selected variable and creates a histogram, which is displayed to the right. The number of histogram classes is assigned by default, but can be changed by unchecking the box Autonome Classes. Change the number of classes, for example, to 4, and click Redraw. The selected result corresponds to the average annual loss for each property in City A relative to its replacement value. This result corresponds generally to the economic value that has to be paid annually in the long term to offset the loss resulting from future earthquakes. A mean value of 0.09 indicates that the average annual loss for any property in the city is around 9% of its replacement value, meaning that the owner of a specific property has to pay annually, in the long term, 9% of the cost of his or her property. This corresponds to a very high-risk situation for this city. Also, the histogram shows that 80% of the buildings in the city have average annual losses of about 6%. This should give an idea of the loss distribution in the city. To view the PML curve, click the View PML plot. This opens a dialog box showing the probable maximum loss curve. Here you can select the type of loss, temporality, maximum return period in the graph, and the loss scale factor. Also, in the lower part of the annual average loss is shown for the entire portfolio of properties. You can copy the graph data or a screenshot into the clipboard using the buttons to the left. To exit, click Close. For better viewing of the results, turn off the seismic hazard layer and set the exposure layer linked viewing properties to border and background. Update the exposure layer's attribute table. To the right of the table, you will find new fields with results by location. These results are saved in a new shape file and are linked by Capra GIS in runtime so they can be consulted as data linked to the exposed elements. In the Capra Project tab, inside the Calculation Parameters tree, under the Process Files tag, you will find a node with the same name as the exposure layer. Inside that node, you will find different risk results. Double-click the PRF node so the exposure layer map is colored in accordance with the values in this field. You can double-click on any other result to color the map in accordance with those values. Now, we will review the results for the entire portfolio. To do this, double-click the PML Total node. This action opens a results text file with an RES extension. This file contains the following data: the number of temporalities and the number of points used for computation of the loss exceedance curve, a table with the loss by scenario. For each seismic scenario, this table contains the following fields: hazard temporality, annual scenario occurrence frequency, expected loss value, loss standard deviation, parameters A and B of the beta probability distribution function that defines loss, and the total exposed value. Below the scenario loss table, you will find the loss exceedance curve for the entire portfolio. The first column of this table contains loss values, while the next columns give annual exceedance rates of those values. Rates are given as a total and for each temporality. In this example, both values are the same. Next, you will find the annual average loss for the entire portfolio for each temporality and a total value. Lastly, Capra GIS reports the 5 worst scenarios, i.e., those generating the greatest losses. This ends this tutorial. Thank you.